Show that if we differentiate this expression, we can write it in the form e to the 3x p x plus q over the square root of 4x plus 1, where p and q are integers to be found. So what we need to do is just go ahead, do the differential and see if we can rearrange it into that form. So I'm going to let y be equal to e to the 3x, 4x plus 1 to the power a half. And that's a product. So u is equal to e to the 3x, v is equal to 4x plus 1 to the half. And so du dx is going to be 3e to the 3x. dv dx is going to be a half 4x plus 1 to the negative a half, and multiplied by the differential of the inside. So that will be a 4, so that tidies up to be 2, 4x plus 1 to the negative a half, or 2 over the square root of 4x plus 1. So for a product, dy dx is going to be v du dx. So that's these two multiplied together. So that's going to be 3e to the 3x square root of 4x plus 1. Then we have plus u dv dx, so that's this one multiplied by this one, so that's going to be 2e to the 3x over the square root of 4x plus 1. So if we look at the expression that we've got here, it's all over the square root of 4x plus 1. So with this first term, I want to write it over the square root of 4x plus 1. And I do that by multiplying top and bottom, if we think about this as being over 1, top and bottom by the square root of 4x plus 1. So this would be 3e to the 3x. And then if we multiply that by the square root of 4x plus 1, we just get 4x plus 1. Plus 2e to the 3x over the square root of 4x plus 1. And so we can just add the numerators now. And if we do that, we can see that we've got a common e to the 3x. And out of there we can take 3, 4x plus 1, plus 2. Then that's all over the square root of 4x plus 1. So that's e to the 3x into 12x plus 3 plus 2, which is plus 5, over the square root of 4x plus 1. So going up to the top here, we can see the values of p and q. We can see that p is equal to 12 and q is equal to 5.